Hi Leah, this is to answer your question how to use a CAS. I believe I don't remember teaching the class this mainly because I'm not too fluent with the spreadsheet, but I played around with it and I now know how to do it. So I'll probably teach the class about this during the revision before your SAC, how to find n values using a spreadsheet. So let's have a read. 14C, you know how to do it by hand. In fact, it's actually really hard to do by hand because it's equal to 3. Actually, yeah, you're right. I couldn't do this by hand because, yep, my question was question 4. Okay, so question 4. This is question 4 here, and let's have a read. So we do know that it seems like selecting chocolates is our X variable. She knows that 20% of chocolates have hard centers, so it seems like X is getting hard centers, and we want to find the minimum number of chocolates she needs to select to ensure the probability of choosing exactly 3. So we want probability of X, which is getting hard centers. We want that to equal to 3, but we don't know the number of trials we need, but we want that the probability of it to be more than 10%. That's essentially what we're doing. Now, normally, if we were to do this by hand, you're right. Because we don't know the number of trials, we know that we want 3 of them. We know 0.2 is the chances of getting them, but then that means 0.8. And the problem is here, where we don't know how to calculate that. That's n choose 3s, very difficult without knowing n, and so how do we know what it is? So you can't do that by hand. So doing a CAS now, going to CAS, if you try to solve it, it's not going to work as well. So the best thing to do is to get the calculator to trial and error as many times as they can to find the probability that we want. Now, in our case here, I'm just going to go Control Enter. We're going to do a spreadsheet. So spreadsheet. Okay, in our case, because it's equal to 3, we're going to be doing Binom PDF as opposed to CDF. Okay, so let's have a look at this. I want to answer question 4. Now, move your mouse or cursor, move it to the equals center, because what we're going to do is we're going to use the numbers on the left-hand side, 1, 2, 3, 4, 5, to be the number of trials. So what if we had 1 trial? So n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. We basically want them to calculate for every one of them when n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, and onwards until we get the probability that we want or more. Okay, so how do we tell it to do that for every value on the X bar or the column bar here? Is you are going to generate what we call a generator sequence. So we're going to go to menu, we're going to go to data and generate a sequence. So if you don't press an equals or anything, you just move your mouse to the box, get menu, data, generate a sequence. Okay, so in the sequence, what are we trying to do? We are trying to do a binom PDF. So in this case here, I'm going to go to the box, and if it comes up randomly, just press the letter B on your calculator. So for example, if I was at identity for now, and then I press B, it'll take me to this, and I'll just move down, and I have choices here. In my case, I want to do Binom PDF, where I don't know the number of trials. I do know the probability I want, the probability of getting what I want, and I also know what value I want as well. Okay, so I'm going to go to PDF. I know that and notice here it's UN. It's a function of U in terms of N, so you can't use X as a number of trials. You actually have to use N. And here we know the chances getting it, what was it again? It was 20%. So 0.2 chance of getting what we want. And how many we want? We want 3, right? And what it's going to do now is going to do trials of when n equals 1 all the way up to n equals 255. Now, most of the time, these textbook questions won't get up to 255. It'll probably be within 1 to 20, somewhere there, right? Or maybe a bit more. But anyways, from 1 to 255, that's all you have to do. So that's my sequence, and I want them to do that for me. So I'm going to press OK. And what it does is it generates a sequence when n equals 1, n equals 2, what's the chances of getting each one? Okay, so it seems like because we wanted x equals 3, it makes sense that if you only trialed 1, how are you going to get 3? If you trialed 2, how are you going to get 3? The only way to get 3 is if you trialed 3. That's why it's 0% chance of getting what you want if you only roll twice. So it's kind of like saying if I wanted two tails, right? When I flip a coin, if I flip the coin, if I wanted 3 tails and I flip the coin only once, how am I going to get 3 tails? It's just impossible. Hence why it's 0. If I flip twice, it's 0 again. The only time that I could get 3 tails is if I flipped it 3 times. So n equals 3 gives me a percentage, providing that the percentage was 20% chance of getting what I want. Okay, so it ends up being 0.08, right? But what we wanted was, how many trials do I need to get more than 10%? At the moment, this is 0.08%. This is 2.5%. So I'm going to keep going down until I get more than 10%, because that's what the question said. They said is more than 10%. So if I'm looking at it clearly, right? Oh, ditto. Reminders. All right, ignore that. This is still sitting at 8%. So when n equals 6, so 6 trials, I get 8%. So at 7 trials, I'm at now 11.4 or 11.5%. So that tells me that I need 7 trials minimum to get more than 10%. Because if I did 6 trials, I'm under 10. So to get more than 10, it had to be 7 trials. So in my case here, n had to be a minimum of 7. That's the answer for this one, right? Now, let's say, just to clarify my the techniques with the CAS, question 5, for example. Let's do 5, right? 5, here we go. Well, I don't know why I didn't copy. Let's do it again. So here we go. Let's do question 5. Question 5 says, find the probability of winning prize. The probability of winning a prize in a game of chance is 35% chance, right? So the question now is, what is the fewest number of games? So how many games do I have to play to ensure that the probability of winning at least twice? So now X is the chances of winning. So probability of winning is at least twice, so 2 or more. And I want that to be more than 90% of the time. So 90% of the time, I want to win 2 or more, right? Now I know on your CAS, I'll show you, in your textbook, I'll show what the textbook has shown you to do, and I'll show you what I'm doing as well. So you get a bit more familiar with the PDF and CDF, right? So here we go. What we normally do by hand is what we would say is, it's too hard to calculate 2 onwards, especially if we don't know the number of trials. So what we do is we say, let's do 1 minus the probability of something we know. So something we know is the chances of, what about X less than 2 to be the 0.9, right? That's what we would say. So that one we can do ish by hand, because we can do 1 minus the probability of X equals 0 plus the probability of X equals 1. That's the only times you're going to get it less than 2, right? Whoops, and it is, does this work? Yeah, good. Greater than 0.9. That's normally how we do it by hand, and then we say 1 minus, what's this? N choose 0, probability was 0.35 to the power of 0, and then what's, that's 5, 0.65 to the power of n, and then plus with n choose 1, where you have 0.35 to the power of 1 times 0.65 to the power of n minus 1. Okay, greater than 0.9, and we try to do this by hand because that simplifies down to 1 and 1, and then you get 0.65 to the power of n plus n choose 1, you get n times 0.35 times 0.65 to the power of n minus 1, right? Greater than 0.9, and we try to simplify this as much as we can before we do it on a CAS to solve, right? Now, let's say instead of doing this whole shebang on the left here, let's stop right there. This is what your textbook is actually saying. They say, how about we generate a sequence that tries 1 minus probability of X less than 2 as many times as we can, try all n values such that until we get greater than 0.9. All right, that's what your textbook is actually doing. So if we go to our textbook, which is this one, if we just have a look at what they're really trying to say in this region here, okay, if we just have a look, see what they're trying to say here is generate a sequence. You don't actually have to do this in the calculator and go to the spreadsheet. In your CAS, what it's really trying to say is 1 minus what we don't want. So in this case here, it was greater than or equal to 2. But obviously, if we want to work the other way around, we can say 1 minus probability of x less than 2. So what is x less than 2? That would be when x is either equal to 0 and x is equal to 1. Which is why they said 1 minus the cumulative probability, because you're going to add these two. You're going to add x equals 0 and add x equals 1, where the chance of success is 0.48 between 0 and 1. That's why it's 0 and 1 here, because you want it to be less than 2. Okay, and then you're going to sequence this, where we don't know what n is, and they'll calculate n up until, and you just scroll down until you get 95% and above, and then that tells you the number of trials, which is 8, right? What I want to show you is that you can do it this way, or you can just simply do what we saw just now. Why don't we just type this part in? Why don't we generate a sequence where you have x greater than 2, and we want greater than 0.9, okay? Now, I'll show you what I mean. Let's go back to this. So I'll do the textbook one, and then I'll do the textbook method, and then I'll do the other method. So you can choose a variety of skills you want, okay? So let's do the first one. First one is I'm going to generate a sequence, a menu. I'm going to generate a sequence, a data, generate a sequence. In this case here, it's a function in terms of n. So I'm going to go to my book, and I'm going to say, all right, I want CDF. So CDF, I don't know the number of trials. I have to use n. I can't use x because it's a function in terms of n. Okay, I know the chances with question 5. What was question 5 again? Where's my there it is. Question 5, chances was 35% chance of winning. So 0.35 chances of winning, and oh, I just realized I need to do 1 minus this. 1 minus this, n 0.35, and because I want it to be less than 2, it will be between 0 and 1, okay? So generate that sequence where the binom CDF n 0.35 is the chance of winning, and I want you to trial it when x is 0 to 1, okay? And 1 minus that should technically be the same thing. So this is the textbook, okay? I'm going to press OK, and it generates it for me, right? So it generates when n equals 1. See, it makes sense that when n equals 1, well, you got 1 and you want 2 or more, so of course it's going to be 0% chance of getting that. You have to have at least 2 trials, and now you get a percentage, right? But the goal was to do it until you get above, what was it again, 90% chance? Was it 90% chance? Yes, more than 90% chance. So I'm going to keep going down until I get more than 90. And you can see right here, at n equals 9, I get 87% chance. So I have to do at least 10 trials to get 91. Okay, so 91 to get more than 90%. So 10 trials, and that would be my answer. So I'll go and check the answers. Chapter 14. Question 5, and it says here, using the CAS calculator, the minimum number of games is 10. Okay, and I've got it. 10 trials that way. Now that's doing the textbook method where I did 1 minus binom CDF n, which we don't know, and 35% chance of getting what we want. And we got 0, we got 1. Okay, now let's say I didn't want to do it that way. Let's say I want to generate a sequence now. Okay, so I'm just going to go back to my point again. So I just did what the textbook taught us, and I did this step. Now I'm proposing we could also do this step. Okay, so you don't have to do the 1 minus step. Okay, let's say we do it this way. We want it so that x is bigger than or equal to 2. Okay, so how do we do that? So in this case here, we still generate a sequence again. Okay, we still do binom. Now I'm not going to have minus 1 minus this. Okay, I'm going to have, again, n trials, I don't know. 0.35 still there, but remember now I want 2. Okay, 2 to infinity. Now, if you put in infinity, it can't calculate that. It doesn't know what infinity is. So we're going to use a very large number. We're just going to say that you either win twice and then or more. Now, I know this is a bit, I mean, unless it's an exam and the answer was like 10,000 or something, then I guess you have to put a higher X value. But instead of saying infinity, I'll just do 100,000. Okay, so that just basically means I want to win twice to 100,000. Okay, I'm going to just keep trialing until it's 2 or more until I get 95, what was it again? More than 90%. Okay, this is the number of trials. I'm going to try at 1 all the way up to 255. Now you can change that n max, but like I said, most of your textbook questions will be between 1 and 20 or 1 and 30, somewhere there. Okay, and I'm going to press enter. What it's going to do is it's going to trial and error 2 or more. Instead of saying 2 to infinity, which is the technical way, the calculator can't do that, so we'll say 100,000. Okay, I'm going to press OK. And what you see is, I want you to see how identical these two techniques are. See, one of them, this one was saying 0 and 1, trial until you get that, and then 1 minus that, right? Or you can do this, which is technically what you're trying to do. You're trying to do binom CDF. I want you to add all the probabilities where you're starting from 2 to technically infinity, but we're going to just do 100,000. Okay, it's a large number. Where number of trials keep increasing, and we don't know which n trial. So we can keep going. We say when n trials is 1, or n is 2, n is 3, n is 4, n is 5. How many times do I have to do it so that I get more than 90% chance? Okay, and you can see it's the same answer that it is 10 trials as well. So I'm trying to show you here that the first one was PDF, when x equals 3. Here I'm showing you exactly the same when it's more than or less than, but the difference between the two is you can do it as 1 minus binom CDF, or you can do it as just binom CDF. Okay, I just want you to understand what you're actually entering into the formula, and it doesn't matter which one. It's like either one works. Okay, either one works. I don't know what's going on there. So either one works. It doesn't really matter which way you want to do it. You can do it this way. I don't know what's wrong with my pen now. It's not working anymore. So that's essentially what I'm trying to say there, that you can do whichever way. So it doesn't have to be 1 minus binom CDF, and you don't have to define it in the calculator before you enter it into the spreadsheet the way that the textbook teaches you. Okay, I hope that clarifies it in terms of how to do those questions. It's in 14C, really, the only one that you'll find difficult that you can't do by CAS or by hand is really the last one, 7. I remember the answer being a very large answer. So you can try that technique that I just showed you and see if you can do number 7. And what's the solution for 7? 7 was 86. See, so that's good because we trial from n is 1 to 255. It would have been calculated within it. So 255 as your n max is good. It should calculate most anyway. Okay, so I'll leave it there. And if you still have questions, ask me on Monday, because or actually I'll do it in class again anyway. I got to make sure that everyone knows how to do that spreadsheet and how to do it this way. All right, but enjoy your evening and take care.